piecewise, but it's okay.
Like
We can do whatever.
like like parent functions and transformations.
Got it. Are you, yeah, okay. So that's really not piecewise by yet. Are you able to see my screen right now?
Yeah,
Okay. All right. So tell me, did you send me the questions or you want to just read them off to me?
I'll just read them off to you.
Okay, go ahead. Tell me what we got.
The first one I'm confused on. It's the square root of 1/2 x plus 2.
Like
Or
that.
the 2 is on the outside of the square root.
Okay. Square root of 1/2 x plus 2.
Yeah,
Okay. It just that, or like
yeah.
you want to know how to transform it?
Like how to graph it.
Okay, so well, first of all, the square root of x function is going to be our base function, right? The square root of x function is our base function. You follow
Yeah,
what I'm saying there?
yep.
So if I take this line and let's make a coordinate plane, trying to make it as straight as I can. It's kind of hard for me to see though. And another one, another line. I'm sure there's an easier way to get a coordinate plane in here, but okay, roughly that's good enough. So the square root of x, the square root of x function is like this. It goes here, and if it's 1, 2, 3, 4, then it goes over 1, up 1,
Okay.
right? Because
Yep.
it's 1. If I imagine plugging in 1 for x, right?
Yep.
And you'd get 1, right? And the next one I'd want to plug in is 4, because what's the square root of 4?
2.
2. So see how I'm plugging in? I'm carefully choosing what I'm plugging in for x. So
Okay.
that's what my graph of my square root of function would look like. Okay, square root of x function. So what am I doing with this blue one here? Well, first of all, I'm taking half of it. I'm taking half of it on the inside though. So instead of instead of over 1 up 1, it's going to be over 2 up 1, right? Because 2 times 1/2 gives me 1, right? You get what I'm saying there? I'll do
Yeah.
the work here. You get what I'm saying? You understand that?
Yeah.
I imagine like I want to just plug in a 2 instead of a 1 because I want this number here to be 1 because the square root of 1 is 1, right?
Yeah.
But also, so at first of all, what it does is it shifts it like this, right? And then it would also be 8 instead of 4.
Okay.
So it'd be like this. So what does that do to the graph? What did that do to the graph? That's called a stretch, right?
Yeah.
See how it stretched it horizontally, or you could think of it as squashing it or compressing it vertically. A horizontal stretch is the same as a vertical compression. Okay. But the other thing I'm doing is the +2 here. So what does adding a 2 to the outside do to every point?
It moves
It
out.
moves it up 2, right?
Yeah.
So the point's going to start here, up 2, right? And then it's going to do that thing where it goes over 2, up 1,
Yeah.
over 8, up 2, right? So that's what the graph is. So it's a stretched and shifted.
Okay. And then if it was like 2x, would it shrink instead of 1/2 x?
Yes. Yep. If it was 2x, I'll do that in green. If it was y equals the square root of 2x, then it would, and everything, because your 2 is on the inside with the x, it's compressing everything horizontally. So it'd be like this. And instead of at 4, think of your points. Like think of what values of x and y you want to plug in, right? You'd want to plug in 1/2, and then you would get the square root of 1, which is 1. Then you want to plug in 2, not 4, because 2 times 2 is what?
Um,
4, and the
oh,
square
yeah.
root of 4 is 2. So you want those nice numbers. You want those perfect square numbers. So just think about what you have
Oh,
to plug in. So it's compressing everything. That makes sense?
yeah, it's starting to make more sense.
So that graph would look like this. That graph it's still the same shape, but it's
Yeah,
stretched now. It's stretched horizontally or compressed vertically.
okay. That's starting to make more sense.
Okay.
Okay. And the next one, it's f of x, 2 in a parentheses, and it's like um x plus 1, like in the cube or something.
Cubed.
Like it's 2 in a parentheses raised by x plus 1.
Oh, oh, got it.
Yeah. And then
So
minus
this
2.
is an exponential. X plus 1 like that
Yeah, and then the 2 is a
minus what?
2.
Okay, like that.
Yep.
The 2 doesn't really even have to be in parentheses
Okay.
because you can see that that's being raised to that power, right?
Yeah.
All right. So all right. So what we're going to do, our base graph is going to be 2 to the x. That's our base graph. And let's just think about what that base graph looks like. You remember how your exponential graphs always go through 0, 1? If
Yeah.
I plugged in 0, what's 2 to the 0 power?
2 to the 0 power 1.
Yeah, what's 2 to the 0 power? It's 1, right? And if
Yeah.
I raised it to if what's 2 to the 1 power?
2 to the 1 power would be uh 2.
2. Good. So there's my next point. What's 2 to the second power?
4.
You get what I'm doing now?
Yeah.
What's 2 to the third power?
2 to the third power is 8.
Good. You didn't say 6. So do you see what's happening? It's
Yeah.
going exponentially. It's going up exponentially. And if I went to the left, what's 2 to the negative 1 power? You remember what 2 to the negative 1 is?
No, I don't.
So 2 to the negative 1 is actually 1 over 2 to the positive 1. You flip it.
Okay.
So it just flips.
So it would just be
So
1.
it's getting closer to 0. As you go to the left, it's getting closer to 0, never touches it. And as you go to the right, it's getting exponentially bigger. It's called an exponential function.
Okay.
Exponential growth function is what that's called. Okay,
Okay.
got it? So
Got it.
what we're doing here for f of x, the one you gave me, is we are shifting it. When I add 2 to the x, what does that do? Do you remember?
No.
It moves it left 1.
Okay.
It kind of it goes in the opposite direction than you would think.
Yeah.
And
Oh, yeah.
what
Yeah. I get what you mean now.
yeah, and what does the minus 2 do to it
It shifts it
on the
down,
outside? Yeah,
down
it goes
to.
down. So this is actually an easy one. Every one of these points just shifts left 1 and down 2. So all of these points go left 1 and down 2. So this asymptote right here is actually shifts down 2.
Okay.
Instead of the x-axis being the horizontal
Yeah.
asymptote, the line y equals -2 is your horizontal asymptote. And so it shifts left 1 and down 2 every point. So that point's there, left 1. This point goes left 1 and down 2. That point's at 0, 0. This point is left 1, so it's at 1, down 2. It's right there. And this point is left 1, down 2. So your graph, it's the same graph, it's just shifted.
So on the test, should I like take my time and like write out the number, like the points or like the values?
Yeah, I would.
Chart.
I
Yeah.
mean, you can do it that way. That's a good idea. Do they let you use a graphing calculator on this one?
No.
Yeah, I wouldn't think they would. If they did, you can just see it in the graphing calculator. You know how to look in the table of values.
Yeah.
So if they let you happen to say, "Hey, I don't mind if you use a calculator or something," then go ahead and just use the table of values. But otherwise, what you just take your time and put in a few points, and then do your shift on all of them. You can even
Okay.
put in the points on this straight up at the beginning. It's just if you don't pick the points right, you might get these points sitting way over here, and you might not realize what kind of graph it is. So you have to understand what the base graph is first and kind of where it usually starts, and then do the shift from there. They
Okay.
really only want a couple points. They really want this point right here, and they want probably the next point, that point there. That's it.
My teacher's always like he needs three.
Or three, yeah. But for this particular one, two is really all you need. Like if you're graphing it on a computer or something, two
Yeah.
points would identify it essentially.
Okay.
Because 2 points help you define that graph for an exponential. Sometimes you need 3 points for certain shapes, but not for this.
Okay.
You got another one?
Yeah. F of x equals minus x in parentheses plus one uh um cube
And
minus one.
cube minus one.
Yeah.
All right. So your base graph is what?
Um.
X cubed, right?
Yeah.
And x cubed. I'm going to do this quicker. It's 0, 0, right? It's 1, 1, and it's negative 1, negative 1. And it goes like this. That's a cubic.
Yeah.
Now the negative flips it over the x-axis. So that flips it like this. Okay.
Okay.
And then the plus one here does what to it?
It moves it to the left one.
Good. So left one. And what does the negative one here do?
It moves it down one.
Good. So all of these points just get shifted. So notice what my points would have been. My green points would have been here and here and here.
Mm-hmm.
So left one and down one. So my new graph, I'll do this in blue, is here. That's the middle point. Left one, down one, that's here. Left one, down one, that's here. So this is your graph. And if you're not sure about it, take those points that you just got and write them out and make sure they're right. Make sure they work. -2, 0. This is -1, -1. And this is 0, -2. And plug them in and make sure they all work. Plug in -2. What do you get when you plug in -2 for x? It's -2 plus 1.
Negative two plus one is one. Negative one.
-1. What's -1 cubed?
Uh, negative one.
Still -1. And what's a -1?
One.
+1. And what's
Oh yeah,
1
yeah.
minus 1? It's 0. So it
Yeah.
worked. Now plug in -1 because now I'm checking this point. Notice I'm plugging the x value in and seeing if the y value is right. Plug
Oh,
in
okay.
plug in -1. What do you get? What's -1 plus 1?
Negative one plus one is zero.
Good. What's 0 cubed?
Zero.
0. What's -0?
Zero.
0. What's 0 minus 1?
Minus one.
-1. So it worked. See it?
Yeah.
And then plug in 0. 0 plus 1 is 1. 1 cubed is 1. 1 -1 minus 1 is -2. So all three of those points work.
Okay. That's starting to make more sense.
Okay, good. Got
Okay.
another one, or is that it for tonight?
I'm looking. I think there was one more I had a question on. Oh, remember those G or F of H or whatever problems we were doing last night?
Uh-huh.
It was like asking for the domain on it. I didn't know what that meant.
The domain just means what X values are you allowed to plug in.
Okay.
So I still have that here. So the domain, what are you allowed to plug in for this one right here? Anything, because it's just a line. For this, you're allowed to plug in anything. It's just a line. Um, this one you might have had you might for this one at the top, you see that one that
Yeah.
there's a domain issue here. There could be a domain issue here because remember you're not allowed to divide by zero. But is
Yeah.
there any way you can make that denominator zero? Is there anything you can plug into y to make the denominator zero in that case? There's
No.
not, because you can't make y squared negative one. So that still domain is all real numbers. But like if it had said y, if it had said, for example, if your equation was x over x squared minus one, then the domain would be x cannot equal plus or minus one. Because
Okay.
if you plugged in plus one or minus one, you'd be dividing by zero, and you're not allowed to do that.
Yeah.
Or if you had a square root of x plus three, the domain of this, remember, you can't take the square root of a negative in the real number system. So you have to make sure that x plus three is greater than or equal to zero, which means x has to be greater than or equal to negative three. So that's the domain. X has to be greater than or equal to negative three.
Okay.
And
Oh,
in interval notation, you would write that as
yeah.
negative three comma infinity.
Okay.
And for this one, you'd write that as negative infinity to negative one union negative one, whoops, union negative one to one union one to infinity.
Okay.
Okay, remember doing that?
Yeah.
All right, man.
That's it.
Think you're good to go. I'll see you tomorrow night.
Yeah.